Let's discuss about the most important part of sets and relation, Venn diagram. Okay, now this particular part, Venn diagrams. See, when we talk about Venn diagram, a very simple representation. It's probably one of the most simple and the most, you can say, efficient way of finding an answer in sets and relation. Okay, it's very powerful weapon. It's a very powerful way of finding the answer, and also it is very simple. So in this case, we'll figure out what is a Venn diagram. Probably you guys already know what is a Venn diagram. Now it's all about how do we represent the things in the Venn diagram. Okay. Now a Venn diagram consists of circles and rectangle. Very simple. Okay. An example you can take. Suppose say you have one and say you have something like this. Okay. It need not be like this. It can be the center also. So this part you can call it as set A, and this is the universal set U. Okay, so this part is set A. Very simple way of representing a set. Now, whenever we talk about Venn diagrams, you can have multiple things like one inside the other, inside the other. Okay, simple example for this is set of natural numbers and everything. See, if you take set of natural numbers, this is set of natural numbers n. And then you have the next one, the whole numbers. The next one, integers. The next one, you have rational numbers. Correct. And then finally we are going to write one big one which becomes real numbers. Again, you can include irrational and all, it's up to you, but generally these are the sets. See, this is also a Venn diagram where you have set inside a set inside a set, and finally the universal set. So Venn diagrams are used for representation of sets. Okay, now what we'll do, different types of operations on Venn diagram we'll discuss. Okay, when we talk about operations, there are two important ones. Okay, union of sets and intersection of sets. These are the two major ones. The others are also there. You have difference of sets, then you have complement of set. Those are also there, but the two major ones are union and intersection. Okay, let's discuss about what is a union, what is an intersection. See, whenever we talk about union of sets. In union of sets, so minimum there has to be two. You can have n number also, but minimum you need to have two. Okay. So suppose say we have two sets. Let's start with an example. Okay. Suppose say I have set A. First I'll give in the set builder form. X such that X is equal to 2k. X belongs to n. X is less than 20. And k belongs to n. This is what we have in the sense x is a natural number, k is a natural number, and the value of x is less than 20. Okay, and also x is equal to 2k, isn't it? Suppose when I take this, so a value becomes, now anything less than 20, we start with, so suppose if I take k value as 1, you'll get x value as 2. So we have the numbers 2. See, it's a multiple of 2, right? So 2, 4, 6, 8, 10, then 12, then 14, 16, 18. No 20, because it's less than 20, isn't it? Now we got set A like this. Suppose say I take another value, as in another set. Suppose say another set is, say set B is equal to y such that y is equal to 4k, where y belongs to n, y is less than 20, and k belongs to n. It's the same ratio, same type of relation. Okay, same type of relation. That means it's a multiple of 4. Now what do we have? B is equal to 4, then 8, then 12, 16. That's all. There is no 20. Now, union is basically it takes the elements of set A, it takes the elements of set B, and then it's going to combine everything together. So, union in the sense it's a combination of the sets. Combination in the sense we are going to take every element within the two sets. That is what we call as union of sets. Fair enough? Now, how do we represent this over a Venn diagram? It's a very important part. For this, there are subtle points what you guys have to notice. Guys, if you look at this, there are certain elements which has been repeated. If you look carefully, 4 is repeated, 8 is repeated, 12 is repeated, then 16 is repeated, correct? These 4 numbers are common in both the sets, isn't it? Now, when we are writing the set, that is the Venn diagram. So, first thing what we have, we are going to have two sets. Sets are represented as circles. So, in this case, so this is the first set. Now, between A and B, there are certain common numbers, correct? That means that since there are common numbers, we write one more like this. So, this part, the middle part is a common part. Okay, now this is the case. Now, this is nothing but A, this is nothing but B, this is the union, correct? Now, what we are looking at is the union of A and B, correct? So, we have to shade it, alright? See, since we are shading it, let me write it in a very simple way. So, whenever we are writing this, remember this part, this entire part, what we are looking at, this is basically the union of two sets. This is basically union. So the shaded part, you can write it like this, or you can also say this entire part, what we are shading here. This entire part is the union. So A union B, we write it like this. A union B. Remember, this U is not universal, it's a symbol for union. Or you can also say that A, so the union looks something like this. This is B, union. Okay, this is A union B. Now, A union B represents what? It represents every element which is there in the set. Okay, everything. That means we are looking at numbers 2, 4, 6, 8, 10, 12, 14, 16, 18. Because 4, 8, 12, 16 are already repeated. So we are not going to write it again. So we are just going to write this one. Fair enough? So this is an example for union. Now since we are looking at union of sets, what we'll do in the next video, we'll look into the properties of union. There are quite good number of properties and important properties which we have to discuss in the next video.